Okay. Yeah, here we go. Sorry about that. I had to double check I had the wrong audio device selected. But I think we should be good now. Let me know if you can hear me. Well, in case you didn't hear any of what I just said because my audio wasn't working, I've had a request for Cal 3 and C++, and so we're going to cover both of those things. Excuse me. We'll do C++ later down the road. Put video low. Okay. If you're watching and you can hear me, let me know in the chat. Because it's saying that my stream health is bad. But it looks fine on my screen. So I'm not sure what that means. Maybe I'll have to relaunch it or something. For now, we'll start talking about this Cal 3 request. So the question asks us to find and sketch the domain of a function of x and y, so a function of two variables, that is equal to the natural log of, and I'm going to change the numbers from the problem given, and that's going to be 9 minus x squared minus 3, nope, not 3, 9, y squared. Now what is it? What is the domain? So in math we have two terms. I'm assuming you just heard me get an email that says I'm streaming. In math you have two terms. One is domain, one is range. So the domain valid inputs. To the function. Range possible outputs of the function. So domain, or if someone says find the domain, they're asking you to find the list of all the possible things that I can put into a function and get a meaningful answer. So what is the domain of this function? Well, the easier question to ask at the moment is, what is the domain of that function? So what is the domain of natural log of x? Well, if we look at the graph, we see that. So this is y, x, and this is ln of x. The natural log is asking what number do I have to raise e to get x? So if I have e to the x equals y, then I'm going to rearrange that. If I have e to the y equals x, and I want to know what do I have to put in for y to get the number x, then I would say the natural log of this whole equation, e to the y equals the natural log of x. Natural log of e to the something gives me the something, so I have y equals ln of x. Now, I'll scroll up a little bit. With this in mind, let's think about this equation for a second. So we'll come down here, and if I have x equals e to the y. Now, if I plug in a number for y, let's plug in 0 just as an example. X equals e to the 0. Well, anything to the 0 is 1. Okay. So what if I put in infinity? If I just keep putting in bigger and bigger numbers for y, what happens to x? Well, x equals e to the 1 equals e to the 10 equals some really big numbers, so it's 2.7 something to the 10. X equals e to the 100. Well, this e is bigger than 1, so it's going to be 2.7 something to the 100, which is really, really big. So it looks like as I plug in bigger and bigger numbers for y, I get a bigger and bigger x. So the limit as y goes to infinity of e to the y, e to the y equals infinity. Okay, so that tells us something. What about if we go the other direction? We plug in negative infinity. So the limit as y goes to infinity, as y goes to negative infinity of e to the y. Well, that just means the limit as the absolute value of y goes to positive infinity of e to the negative y, or 1 over e to the y. And we've already said this goes to infinity, and so we'll plug that in there, and so that's going to be equal to 1 over infinity, which is 0. 0. All right, so the further and further we go negative with y, the closer we go to 0. So now let's take these and translate these back to this ln equation. So if I plug in 0 for, negative infinity for y is equal to some value of x, or natural log of some value of x. From this experiment we did down here, we know that has to be 0. And if you think about it, that makes sense. Because no matter how big no matter how big a number you put in for y, how big a negative number you put in for y, this will never be 0. It gets closer and closer and closer and closer to 0, but it never actually is 0. So the number 0 not in the domain of ln. And looking at the graph, we can see this, because there's nothing to that side. So nothing here. that answer changes if you're in the complex numbers, but we're not in the complex numbers. We're dealing with Calc 3, so we don't care right now about the natural log of a complex number. So if we're asking for the domain of this function, we're really asking the question, where is this expression 9 minus x squared minus 9y squared greater than 0? And that's a question that we know how to answer because we have algebra. So if we say 9 minus x squared minus 9y squared is greater than 0, then we'll rearrange a little bit because we can, I think. I'm terrible with factoring. Hang on. This is going to take me a second. Is the stream still says it's running? Okay. Okay. So we have a bunch of square numbers here. So maybe 9 minus x squared minus, nope, hang on, stop it. 9y squared minus x squared greater than 0. Can I do it this way? 3 times 3 minus, nope, 9 minus 9 times 1 minus y squared minus x squared greater than 0. We do it that way. So we have 9, 1 minus y squared is greater than x squared. So x squared is less than 9 times 1 minus y squared. If we do the square root of that, no, we shouldn't. Stop it. You know what? I'm bad at factoring, so I just use a quadratic formula for everything. So we're going to quadratic formularize it. We have x equals negative b, which in our case is, what is it? 9, no, hang on. I can't quadratic formularize this. Can I? Maybe I can. I don't know. 3 squared minus 3 squared y squared minus x squared is equal to 0 for now. And I feel like I should be able to do something with this. I can pull out the 3 squared, so 3 squared times 1 minus y squared minus x squared equal to 0. Then I can do 1 minus y squared equals x squared over 3 squared. And if I do the square root of that, which I shouldn't do, but for the sake of experimentation, I got 1 minus y squared under square root equals x over 3. That's plus or minus. That doesn't seem right. Hang on a second. Okay, well, there's not an easy way to do that than what I've already done. But I can get this into a form that we can recognize, which is the important part now. Let's bring this back around. Okay, so this is not a quadratic or anything that I can do with a quadratic. This has a form that I didn't recognize right away, and I should have. Stop that, stop that, and stop that, and fix that as well. Okay. Don't need any of that. Or any of that. Or that. This looks like, if we set it equal to 0, let's do the equals case temporarily. This looks like to me 9 equals x squared plus 9y squared. And that should look familiar, because then we have x squared equals, no, x squared plus 3y squared equals 3 squared. And that looks to me like it's in the form a squared plus b squared equals c squared, which is a circle slash ellipse. Which tells me we should be looking at a circle or an ellipse for our shape. Now, we got to remember that we're dealing with an inequality, so let's go back and fix this equal sign business and change it to the proper direction. This is less, nope, not less than 0, greater than 0. That's greater than 0. I'm going to change my color. Greater than 0. So 9 is greater than that. Like so. Now, this looks like we're talking about the inside of the circle, because we're talking this radius is less than some max radius. So we should have if this 3 here was a 1, it would be a perfect circle of radius 3. 9, radius 9. 3, radius 3. But it's not. It's a 3. And so on our x, we have, let's temporarily set y equal to 0. So we'll figure out where we fall here and here. So in order to get x squared to be less than or equal, for the sake of the graph, to 3 squared, if y is 0, then x has to be 3 or negative 3. So this is negative 3 and 3. Now set x equal to 0, and then 3y squared is less than or equal to 3. Less than 3 squared. And we have 9y squared less than 9. Yeah, 9. We'll divide out the 9. Y squared is less than 1. Y is less than plus or minus 1. Negative 1 less than y less than 1. Negative 1 and 1. And so we have, do I have an ellipse tool? I don't have an ellipse tool, I don't think. Like that. And like that. And that is our region. Try and neaten that up a little bit. And that is the domain, found and sketched. Let's see, how much time do we have? 23 minutes in. For the sake of completion, let us plot that. Why is this? Oh, there we go. Because we can. Wait, I gotta switch so that you can see what I'm doing here. Pie charm. There we go. From plane evaluator, import Cartesian plane. I'm going to import Plotly. From Plotly, import graph objects as GO. And import Plotly as PLT. Set that over there temporarily. Anything else from over here? Nope. NumPy. Import NumPy as NP. All right. So I want to create a plane. So main plane equals Cartesian plane. I want my x-min to be, according to our thing, we don't need it any less than 3, but I want to see past the edge. So let's do negative 3.5. Max is going to be 3.5. Y-min said, math said we didn't need any less than 1. So I'm going to do negative 1.2, just so we can see past the edge. And 1.2. And DPU 0.2 is going to be 100. Well, yeah. So in case you didn't notice, we're using a black background now instead of a white background. My monitors died over the weekend, so I got new monitors, and these are actually HD, not something weird and non-standard. In fact, these are 2K, and they're big, and they're really bright, hence the black. But what that means is now I need to do bigger bigger plots in terms of pixels. That way you can actually see stuff. So instead of 100, we'll do 300, just for now. We can change it later if we need to. So now we want x, y equals plane dot, what is my function grid. Creates the grid automatically. X, Y equals plane dot X, plane dot Y. And Z is going to equal our function. And our function was, bloop, 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 I'm going to bring it up so that I can see it, and you'll just have to remember it. Z equals log, which I believe by default is natural log, of 3 minus x squared minus 4 times y squared. Not 4. The original problem had a 4. 3. And it's not 3s, it's 9s. Surf equals go surface x surface, yeah, x equals x, y equals y, z equals z. Layout equals, come over here and still layout from over here. Layout equals that. That's probably fine. I'll change that to match 3.5. 3.5. And I'll actually go ahead and change these two. That way my aspect ratio is right. Aspect mode cube is fine. Figure equals figure data equals surface. Layout equals layout. plt.offline.plot figure. Invalid value encountered in log, that's fine. I'm gonna have to be able to bring up my figure now. As soon as it pulls up, I'll start showing it. I guess I can go ahead and show you the pumpkin from before. I may need to reduce the number of points. Yes. Oh, nope, you can see it. And what do you know? But if you look carefully, I can see it in my plot. I don't think you can see it in yours. At least not well. The minimum x value is -3. The maximum x value is +3. The minimum y value is -1. And the positive y value is +1. And it exists only in that space, which is exactly what we predicted from the math. Which is fantastic, because that means I didn't mess up. So with that one done, let's do the next problem. And the next one on the suggestion list is use the second derivatives test to find the local maximum and minimum values and saddle point of the following function. All right. Second derivatives test. Okay, so this problem I'm going to abbreviate. And then I'm going to use my color again. Find local min max saddle points of the function f of x y equals y cubed plus 3x squared times y minus 6x squared minus 6y squared plus 2. That's the function they gave me. I'm going to change some numbers around a little in ways that shouldn't affect the outcome of the problem. We'll do we'll do a 4 here. We'll do let's not do a 4 there. We'll do a 5 there. We'll do a 10 there. We'll do a 10 there, and I'll do a 2 here. All right. Now, if we want to find the minimum or maximum of a function in one dimension, so some function of x, we need the derivative. If we want to confirm that it's a maximum or a minimum, we need the second derivative. So let's start finding our first derivative. But since we have two variables, we have to pick a variable to take the derivative with respect to. So we'll take the derivative with respect to x first. Derivative of y cubed with respect to x is 0 because y cubed doesn't vary with x. 5x squared times y, taking the derivative with respect to x, is going to be 10x times y from our exponent rule. Negative 10x squared, derivative with respect to x is 20x. Derivative of 10y squared with respect to x is 0. Derivative of 2 with respect to x is 0. So we're left with 10xy minus 20x. And if we want to, we can factor our stuff out and go 10x times y minus 2. Now we'll do the derivative with respect to y, which is how we, this subscript x and y is how we denote that. So derivative of y cubed with respect to y is 2. Nope, it's not 2. It's 3y squared. And then plus derivative of 5x squared y with respect to y is 5x squared. Derivative of 10x squared with respect to y is 0. Derivative of 10y squared with respect to y is 20y. And derivative of 2 with respect to y is 0. So we're left with 3y squared plus 5x squared minus 20y. And I could probably simplify that, but I'm not going to. So if we want to find a maximum along x, or a critical point, I should say, along x, we're going to say, okay, f of x, or f derivative with respect to x of xy is equal to 0. Stop that. Write correctly. Y minus 2. critical points. So 0 equals 10x times y minus 2. Now the critical points of this is anywhere, anywhere that this quantity is equal to 0. So whatever values I have to plug in to get 0 are fair game. Hey, welcome to the stream. If you have any questions, feel free to ask. Right now we're doing some Calc 3 suggestions. This was a problem request, and so I'm working it. So since we're trying to find a critical point, we want to know what values for x and or y should I put in to make this equation true. So we'll start with solving for y. I'm going to divide out my 10, so I'm going to end up with, let's change colors. 1 divided by 10. I'm going to have 0 divided by 10 is 0 equals x times y minus 2. Well, temporarily going to let x not equal 0, so I'm going to divide by x. Zero divided by x is 0, because we're stipulating that x isn't 0. 0 equals y minus 2. Y equal to 2 will make this 0. So if I plug in a 2 for y, then I get 2 minus 2 is 0. 10x times 0 is 0. So that's a critical point. So we need to remember this one. What about the other way, if we're trying to find what value for x? We got 0 equals 10x times y minus 2. We're going to divide, change to red. Wish I could hotkey that. I don't know how to do that. Y minus 2. Temporarily disallowing y from being 2. So we're going to do 0 equals 10x. And then divide by 10. So then 0 divided by 10 is 0 equals x. So x equals 0 is a critical point. Now we got another equation to do. This will be a min and a max. Not sure which is which, or if they're different, who knows. Given that this is a third order equation at the max, we will have probably one of these will be a min and one will be a max, I think. We'll see. We'll get there. Actually, we'll do our second derivative test here in a minute. So, more critical points. Fy of xy equals 3y squared plus 5x squared minus 20y. So what values of x or y make this equation 0? 3y squared minus 20y plus 5x squared. This looks like a quadratic to me, so I can probably factor it, and I'm garbage at factoring. So let's solve, I guess. We'll see. 3y squared minus 20y equals negative 5x squared. I just subtracted 5x and flipped the equation around. So we have 3 times 3y. Nope, we have y times 3y minus 20 equals negative 5x squared. I don't think this is going to work. Yep, gonna have to use the quadratic formula. Alright. Cool beans. Alright, so I'm gonna use a quadratic formula with respect to y, not x. I see it. Will I graph this? Yes, I will. We'll get there. We'll get there. One step at a time. Alright. Let's find our roots. So we'll use a quadratic formula with respect to y. So we have y equals negative b, which is going to be negative 20, which is positive 20, plus or minus the square root of b squared, which is 400, minus 4 times a, which is 3, times c, which is 5x squared, all divided by 2a, which is 3, 20 plus or minus square root of 400 minus 12 times 5x. 12 times 5 is 60. 60x squared over 6. I hope the numbers that they picked weren't important. I'll factor 100 out of this. So we'll have 10 times the square root of 4 minus 0.6x squared divided by 6. Just to help consolidate a little bit. Divide out of 2, we'll have 3, we'll have 10, we'll have 5. So 10 plus or minus 5 square root of 4 minus 0.6x squared over 3. Alright. This is not getting any prettier. And I don't know that it would have been any prettier the other numbers either. Probably would have been. But this says to me that we have a line. Probably it's not a straight line either. It's got some curves to it, but I'm not sure what curve yet. That one maybe we should plot. Do I have a plotter in here? I think I do. Interactive? No. Where is it? Applications. Graph me. Yes. Oh, I do have a 3D grapher. Alright. So yep, okay. So let's do 10 plus 5, and I know there's a plus or minus, but it only lets me do one at a time, so can I insert a square root? Whoa, hey, nope. 10 plus 5 times, I'm assuming that's how that works, 4 minus 0.6 times x to the 2 divided by 3. Add. There it is. Whoa, come back. There we go. Stop. There we go. So it's part of a circle looking thing. So there's a range of values for y that will give us 0 in this function, and they satisfy that equation. Maybe better off. Can I hide this? Nope. Okay. Oh, that's not better. I don't like that at all. Just hide. Just, yeah, here we go. That's fine. Okay. Hey, welcome to the stream. All right. So we have this function, this range of values, and I'm not sure what to do with this. I'll be entirely honest. It's almost like there's a cusp, but that doesn't make any sense. It shouldn't. No, it doesn't have a cusp. All right, well, we'll see it when we graph the equation. We'll start with the easy ones over here because I know what to do with that. Yeah. That's bothering me over there. Let's hey, you thing here. Go away. I'm done with you. We'll do our second derivative test on these 2 points because we know what to do with them. So if we have f of x, y, fx, then over here we'll have f, the derivative of f with respect to x, take the derivative of that with respect to x. And that's going to be equal to 10 times y minus 2. And then we'll do the same thing, f derivative with respect to x, and then take the derivative of that with respect to y is going to be 10, this is 10x times y minus 20x. So the derivative of this with respect to y is going to be 10x. Derivative of that with respect to y is going to be 0, so we'll do plus 0. Now, 10x is going to be positive for x greater than 0, and it's going to be negative for x less than 0, and it'll be 0 when x is equal to 0. Over here we have over here we have this equation, so with respect to x. Hang on, I'm thinking. Yeah. So if we plug in y equal to 2, so f, x, x, all values of x when y is equal to 2, then we have 10 times 2 minus 2 equals 0. So at y equal to 2, let's create a graph. So this is a 2-dimensional graph because drawing 3 is hard. Repeat which section? I'm thinking through this with you. I'm gonna get started on the graph. So if this is our y and this is our x, then for all values of x where y is equal to 2, this is 2, then all the way, it's not perfectly straight, it's fine. Then for all of that, f that's 0. So that is an inflection point? Maybe? When x is equal to 10 part. When x is equal to 10? I don't have when x is equal to 10. Did I say somewhere x is equal to 10? I don't think so. I don't know. If I said somewhere that x is equal to 10, it was not correct. If x is equal to 0, then the derivative of the function with respect to x and then with respect to y will be 0. So let's do that part. Let's switch back to white. F of x, y of x of 0 y is equal to 0. 10 times 0, which is equal to 0. So in both of those cases, we have the second derivative at our critical point is 0, which means it is neither concave up nor concave down. It is flat. Which is interesting. So then we have another one right here. And that's going to be f x y x and y equals 0. So that is probably, those two are probably ridges, either maxes or mins. And I think if we plug in to the opposite equations, it'll work. So f maybe not. If we plug in x equal to 0 on this equation, it doesn't make any difference because there's no x anywhere on here, which would mean that for it means nothing. It means this second derivative is not changing at all. Which implies that it's, I don't know. I'm thinking. Plug into this equation. Y equal to 2. It's like we have a ridge. Yeah. Yeah, let's go ahead and graph it, because I think that's going to help us. That'll help me. Go back to PyCharm. This one. Not sure why it's not showing my ref from earlier. Okay, so I'm going to comment that one out, and we'll plot it. The new function, z equals looking back at the other thing, y cubed plus 5x squared y. We'll do y cubed plus 5 times x squared times y minus, I believe, 10x squared minus 10y squared. There's a pattern there that I should be following. 10 times x squared minus 10 times y squared plus 2 plus 2. Then I'm going to change this range because I'm sure it's valid for more than that. Negative 10 to 10, negative 10, 10, and I'm going to change that density back down to 100 because I don't think I need much more than that. This formula. By the way, for those watching, if you want to send in a request that's a little awkward to put into a chat or something, I have a Discord server that you can join. There's no cost or anything. You just join the Discord, and you can post pictures and stuff in my stream chat. Okay. Come on. I need to update that. I should update here in a second. I have to change that number down even further. Oh, that is really weird looking. I don't know what to do with this information. You don't get to see the whole picture because of the way this plot is working. I may have to change this so that you can see it. But we're going to have to change z-axis from being negative 10 to like negative 100. And that's going to be 100. And I don't need 500 points. Let's go with 50 instead. Yeah, should be a link in the description. You can follow the link, and it'll take you to the Discord page. And if you don't already have a Discord account, it'll walk you through setting one up. Oh, interesting. All right. Let's change this C to be 500 and 500. Time is it now? Okay, good. Track. All right, and that's all the interesting points, really. Okay. So let's adjust our range. We no longer need y going from -10 to 10. We need -3 to +13. Sure, nah, we'll stick with 10. I'm cheating, I'm looking at the graph, which you probably won't get to do right away. Yeah, it's fine. I'll be here for at least 5 more minutes. I haven't even got to the C++ stuff yet. Did it let you join the Discord server yet? Yes, it did. There we go. You should be able to post a message pretty soon. I don't think I have a setting that I've tweaked for that. Where am I? I'm lost. Here. I need this one. Okay. Very good. Back to the graph. Yeah, I'm cheating and totally looking at the plot to go. I can adjust my bounds to this and still be okay. Just to kind of help smooth things out and have quicker updating plots. Why is my x going to -10? I did not say to do that. That's weird. Run it again. X-axis, -5 to 5. This should be -3 to 10. That is not particularly useful. I don't know. Oh, because it's because it's X first and then Y. Changing the wrong numbers here. -3, 10. Try this one more time. And then it should update in such a way that I can send it or change my thing and it'll work. Yes, very nice. Refresh. All right. That is a little bit better. I wonder if I can swap that. I probably shouldn't. Let's change this so that you can see it. Here we go. So this is what I get to see when I'm looking at the plots. And I can scroll it around and stuff. So what we see over here in this area is a local max. What we see down here in this area is a local min. And then a saddle point is a minimum in one axis and a maximum in the other. But I don't see a minimum in one axis and a max in the other. So this spot right here that we're looking down, where it's all flat, that's at y equal to 2. Just like we predicted in the math. We had another one where where x was equal to 0. And so we have a max here and a min there. Right. Right. So, weird. When y is greater than 0, y is greater than 0. How do I describe this? Maybe that's a saddle point. No, it's not. Is it a max in one and a min in another? No. I'm thinking. It's been a long time since I did saddle points or anything. That's a max. We don't have a min in the same place. Yeah. Yeah, so none of this can be a saddle point because we don't have a max in one axis and a min in the other. So there's no saddle points. It's just a local max and a local min. I believe we have an inflection point right here. Oh, that is so funky looking. I love Plotly. Plotly is so cool. But I believe right here where y is equal to 2 is an inflection point, or an inflection line, if you will. Let's see, got a question over here. Should be able to, okay. Answering a Discord question. Plus links to the text entry box to send an image. This one's tripping me up a little bit. I'm not sure what to think. I may have to revisit this one another time. Not that. There we go. As it is, though, I can notate what I do know here correctly. Since since this is the case, we have an inflection point, an inflection line, or a line of inflection points, however you want to think about it. Line of inflection points along y equal to 2. Not inflection points. Inflection points? Yeah, inflection points, because the second derivative is 0 means you have an inflection point. Because you're transitioning from concave up to concave down, or concave down to concave up. Yes, okay. I'm not crazy. I'm just rusty. Same thing here for x equal to 0. If we switch back to the graph. Not that. That. With that. So along x equal to 0, it's not a transition point or an inflection point, which is weird. But it is the line that contains all of the local maximums, no matter how you slice it. Oh, that's weird. Go back to the home view. Let's also adjust that graph. I want to go from negative 250 to positive 250. And have this update. There we go. That's not better. It's not better. I'm cheating to make the colors work better. Clip negative 260 to 260. Oh, I got a picture. Did in the Discord too. It may be to send pictures, you may have to be using the app, not the web interface. Can I work this one? Okay, yeah, we can work that one. This probably shows the details a little bit better. Okay, so we've got another Cal3 request. Which is, and correct me if this is not correct, I have D equal to F XX of A comma B, and then I have FYY of A comma B is equal to, is that equal or is that, nope, that's not right. I see it now. Times FYY of A comma B minus f x y of a comma b squared d greater than 0 and f x x. This upside down a without the crossbar is math notation for and. I just use it as shorthand because it's handy. That means f of a b is a local min d greater than 0. I seem to recall this. And f x x a comma b less than 0 means f of a b is a local max. So this is not a problem to be worked. This is the criteria for determining things. A reminder for my rusty brain. If d is less than 0, then f of a b is neither. Aha. Very well, very well. Okay, so if we go back to the previous page and we use that formula, which fxxab times f x, is that xy or yy? Yy. Erase. Yy of ab minus fxy. So if we evaluate, oh, and I see now how this is supposed to work. Okay. Interesting. Okay. So if we plug in let a equal 0 and b equal 2. We got to try all the combinations of the points, which isn't too bad. We can do that. Then d equals fxx of 0, 2. fxx is 10 y minus 2. So 10 times y, which is 2, minus 2, times fyy. We have not done yy or yx, but we can do that real quick. fyy, or yx of xy equals, take the derivative of this with respect to x, 0, this with respect to x is 10x, and that with respect to x is 0, and then we have f of y is of 3y squared becomes 6y, and sideways, derivative of that term with respect to y is 0, and so then we have minus 20. Okay, so 2 times 3y minus 10. This becomes 2 times 3 times 2 minus 10. Can I highlight in this very strange marker board thing? Okay. And then we don't have to do both yx and xy because they are in all of the cases that you will probably see in Cal 3, unless your teacher specifies otherwise, they're going to be the same. Because they break a bunch of rules if they don't. So xy and yx are the same, and that's just going to be 10x, just like we saw up here. So this is going to be minus 10x, which is 0. So we have 10 times 2 minus 2 is 0. 0 times that is 0. Minus 10 is 0. So d is equal to 0, which means it's neither a min or a max. Which, if we go back to our chart, can I bring up the chart? Can you see the chart? Yes, you can. So if we look at y equal to 2, x equal to 0, that's right here. Ish. Right there-ish. Come on, mouse. Close enough. And that point is neither a min nor a max. Just like that formula said. So now we have to do another thing. We have to intersect these two options with this equation. So we need to pick y equal to 2. So 2 equals, and I could plug it into this equation, but this is going to get messy. So this is going to get messy. So I'm going to plug it into this one and use this equation again. 0 equals 3 times 2 squared minus 20 times 2 plus 5x squared. So then we have 0 equals 3 times 4 minus 40 plus 5x squared. 0 equals 12 minus 40 plus 5x squared. Um, 40 minus 12 equals 5x squared, and that's going to give us 28. So we have x equals plus or minus the square root of 25 over 5. 28 over 5, goodness gracious. 28 over 5. So that's 2 more points to check, both of which are not meaningful. Because if we look back at our graph, nothing happens. Nothing interesting happens when x isn't equal to 0. Oh, wait. Oh, yes, it does. I found the saddle point. You see it? Because we have a minimum in this direction and a maximum in this direction. So that's a saddle point that doesn't happen along one of the cardinal directions. He's a sneaky one. So that point is important. Now we'll pick x equal to 0. Then we'll have 0 equals 3y squared minus 20y plus 5 times 0 squared. 0 equals 3y squared minus 20y plus 0. So then you have 0 equals 3. Nope. You have y times 3y minus 20. So then you have 0 equals y, or 0 equals 3y minus 20. So then 3y would equal 20, y equals 20 over 3. So now we have 2 more points to look at. So come back over here, and we've got more points. X equals plus or minus the square root of 28 over 5. And we have y equals 0, and y equals 20 thirds. And for the sake of completion, I'll go ahead and write the other ones on here too. 0 and 2. So let a equal so we don't actually have to check all of the possible combinations, because up here we let y equal 2 and x equal this number, but if y is not 2, then this number is irrelevant, right? Because this number only occurs when y is equal to 2. So we'll do let a equal plus or minus the square root of 28 over 5, and b equal to 2. Then d equals, and I need to probably note this one as well, 10 times 2 minus 2 times 2 times 3 times 2 minus 10 times the plus or minus square root of 28 over 5. Well, we know this all goes to 0, so that's 0 minus 10 times plus or minus square root of 28 over 5 equals minus or plus. And I don't know if this is universal syntax. No, that's good. We're almost we're almost through this. I've got it figured out now. I don't know if this minus plus syntax is standard, but I use it because you normally have plus or minus, but then it's multiplied by a negative, and so I want to keep that straight in my head. Says minus plus 10 times 28 fifths. Which is positive in one case and negative in another. So for x equal to the positive square root of 28 over 5, we have d is less than 0. For x equal to the negative square root of 28 over 5, we have d greater than 0. So we go back to our criteria. Greater than 0, local min. No. Greater than 0, and that, I believe, has to be greater than 0 as well. Yes. Okay. Go back. All right. So we can disregard this case because we don't care. We only care when d is greater than 0. So for this one, now we can check f of xx. So f xx of the negative square root of 28 over 5 when y is equal to 2 equals ten times y minus 2 that's 0. Is it? Is that right? Because that's at y equal to 2. And this way is probably the 28, square root of 28 over 5. If we do 28 over 5 square root, that's 2 point something. And looking at this graph, that's definitely 2 point something. So that's our saddle point. It's a min in one direction and a max in the other. Interesting. I would have expected to be positive. No, well, it can't be positive and negative. It's 0, which is, I guess, the closest thing you can get to positive and negative, so it's a saddle point. So, negative. Those are saddle points. And then the other one should be fairly trivial, because that's just a fraction. So then let equal 0, b equal 20/3, and d equals 10 times 20 over 3 minus 2 times 2, 3 times 20 over 3 minus 10 times 0 equals 10 times 20/3. Trying to work through this one quick because it should be fairly easy. Equals -14. And if I did my math right, that should mean it's neither a min or a max. 20/3, 6-ish. And if we go back to the graph, we see that it's a min, so I've done something wrong somewhere. I'll have to revisit this one at some point when I have sufficiently reviewed, because this is not all adding up correctly. The graph is fine, and we found that the saddle points exist, but I'll have to look back at it. So for now, let's move on to the programming questions, which should be fairly simple. I didn't have a straight question other than having trouble with C++ and C arrays. So C arrays. An array in C, you have whatever data type you want. So type, and I'm using the angle brackets to let you know it's an optional field, and then it's going to be square brackets to tell you it's an array, name, var name equals, and then you can initialize it. This is an optional length as well. This one you don't have to put in, so I'll put it in red. Length. You can also initialize it here, so use a curly brace and then 1, 2, 3, 7, 12, -5, 11. You can initialize it that way, and it will auto-compute the length, at least in some compilers. Double check in your situation to see if that works. And the way this is all set up, if you want to access one element, so third element is equal to var name number 3, right? No, that is incorrect. And that is incorrect because it is 0 indexed. So if I want the third element, I gotta count 0, 1, 2. But that's the third. So I'm gonna do 2. And so that's how you retrieve an element. If you want to set an element, you can do var name 6. I'm going to set the last one equal to 0, just because I can. And so that will put a 0 in this place. If I want to pass this to a function, and this is, if I was going to guess what it was you're having trouble with, it's probably this. If I want to pass an array to a function, I can't just pass the array. I have to pass a pointer to the array into the function along with a length, so it knows where not to index past. So I'm going to have a sum function. I'll make it a void function for the sake of example. Void function. I'm going to pass it a pointer to the array, so type pointer. I'm going to call it array or array, and I'm going to pass it a length. Int. And if I want to iterate through the array inside of this function, right now this is going to give me, what if I say type var equals I believe that's correct. Because if I put the star on it, hang on, let me double check because this is tricky. Pointer points to, okay. Stop that. Okay, I'm having a look at some documentation here. Okay, equals star. So that will dereference, and now this will have the value puts if I call the function up here, function of var name, and I'm passing the length of 7. Puts the value of var name 0 into var. So what this does right here, this will put, this passes the pointer to the first element of var name into the function. The other thing you have to keep in mind is, since you're passing in the pointer to the first element, arrays are stored sequentially in memory, which means if you were to if you wanted to move along this array, all you would have to do is say pointer pointer or idx type idx so I tell it I want a pointer, which is the star of the type and named idx, that's going to point to array. And I don't put the star on this one because it's already a pointer. And now if I want to move to the next element, all I have to say is var equals idx plus 1. And I put the parentheses around it because idx contains the address that I'm looking at, and I want to look at the next one. And then I put it in parentheses to say this whole thing, I want to dereference it using the pointer, or using this star. And that this whole thing says go to address idx plus 1 and give me the value that's in that address. And then put that value in var. Probably easier to think of arrays or think of pointers in terms of mailboxes. I've used this illustration before, maybe not on here, but if you have a pointer, what you have is an address. When I put the star in front of it, I say, go tell me what's at that address. So it's like somebody walking up to your house and saying, oh, there's a White House at that address, or Jim lives at that address. But if I say and, so side note, if I use and Jim, that gives me Jim's address. Jim's address. So if I say DDR, right? But if I want to know what's at Jim's address, then I can do stuff equals what's at the address of Jim. Likewise, over here, we're giving you the address of this array, the first element of that array, and I can say, okay, what's at that address? And it'll tell me. And if I want to know what's the next thing in the array, I walk up the street one and say, okay, what's at this person's address? And it'll tell me what's at that address. As far as I know for a fact you can't pass an array back. So you couldn't do like return some new array. You can't do that for a multitude of reasons. You could, in theory, return the address to a new array. And you should not ever do that, because as soon as this function exits, the array that you have created goes out of scope, and your operating system will automatically deallocate it, which means the array no longer exists, and you've passed back an address to a street that doesn't exist anymore. And that'd be like sending somebody to walk off a cliff to an address that has fallen into the ocean, for example. Just to keep up with that analogy. It's just bad, and you shouldn't do it. So those are the things that I can think of that would trip up somebody as they're messing with C or C++ arrays. If you have any other questions, feel free to ask. Join the Discord. I check it periodically. It notifies me. And if I can't answer your question there, I may answer it in a stream. There may be people that frequent or that come back and visit the Discord that are more qualified to answer a particular question than I can. So come join the squad. Hit subscribe if you enjoyed. Hit the like button. And we'll see you guys next week.